So next lesson is, or next unit is graphing sine, cosine, tangent. And the better you know the unit circle, the easier it is to graph these. So that's good news for most of you. A few of you said you'd be out this Friday. It's not an awful day to miss. In some ways, we're going to learn everything we need to know. We'll learn the graphs today. We'll learn the transformations tomorrow. And then after that, it's all practice, and given parameters is going backwards. And then given graphs is going backwards. We've got a review day in there. So like everything we need to know we'll learn today and tomorrow. And then it's just practice, practice, practice.
So this unit should be easy.
Well, should the unit be easy because it's only two things? Yes, in that it's only two things, but no, because we got 2 weeks to learn these two things. So if you pick it up quick, yeah, it's easy, but we do allow plenty of time for you to figure it out. So let's look at the notes page. Graphs of the 6 basic trig functions. And some of you, not some of you, like one of you, one person in one of my other classes moved here mid-semester, and they had done this first. And so she kind of does it backwards from how you would think. We think about our unit circle and then put those values on this graph. On her unit circle test, she had these graphs drawn and was going the other way, using these graphs to answer the unit circle questions. So they really go together. We teach it unit circle first and then do the graph. But then once you know the graph, you can use the graph to answer unit circle questions, which is what this student did. So her test looked completely different than everybody else's, but she did great because she knew what these graphs look like. All right, let's start by making a table of values, right? Whenever you're graphing something new, that's almost always what we do first. So a table of values, and you'll notice we don't use all of the unit circle values. That would be a lot, right? 0, pi over 6, pi over 4, pi over 3, pi over 2, all the way around. We're just counting by pi over 2's. And we'll see what happens. In fact, because we know our unit circle so well, we can pick on people for this. Which reminds me, I need to get Emma a popsicle stick so she can, I don't want you to feel left out. All right, so in order, Brandon, what's the sine of 0? 0. Jake, what's the sine of pi over 2? Yep. Danny, how about the sine of pi? Let's see, pi's over here. Sine of pi? 0. Noah, sine of 3 pi over 2?
That would be 0. -1.
And Luke, the sine of 2 pi?
0.
So now we have some xy coordinates. Let's plot those on the graph. 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, -1, and 2 pi, comma 0. Now, before you play connect the dots with this and have a jagged triangle looking thing, let's put a few more on there. What's the sine of pi over 4? Or all the over 4s, really? Square root of 2 over 2. So anything over 4 is root 2 over 2. And then, I don't know what root 2 over 2 is, so if I look on or grab a calculator, root 2 over 2 is about 0.7. So those first 5 points we did, those are the 5 key points I want to see on all the graphs. But to get a better feel for the shape of this thing, at least for the first one, all the over 4s are at 0.7. So pi over 4, comma, is not halfway, so it doesn't make a triangle. It's a little bit more than halfway. And same thing with 3 pi over 4. The y value is 0.7. And then the same thing for 5 pi over 4. It would be negative 0.7. 7 pi over 4, negative 0.7. Now we get a little bit better feel for what this graph looks like. It's not jagged. It's nice and smooth like that. What do you think happens after 2 pi? Think about what happens on the unit circle. After you get to 2 pi on the unit circle, if you've rotated all the way around, it's just going to like repeat itself. So we're going to take this same picture and repeat it sort of in the next window. So we start at 0, and then we go to 1, and then we go down to 0. And even though we're off the grid, let's go ahead and finish to get 2 full cycles. Down to negative 1 and back up to 0 at 4 pi. Now, we don't need to fill in the 0.7s. We filled in the 0.7s one time just to get the idea that this thing is curvy, not jagged. So let's just repeat this cycle into the next window. What happens if we go backwards on the unit circle? It's just the same thing. So I'm going to take that sort of, it's not really the parent function, it's that first cycle, and now I'm going to copy it backwards. I'm going to copy that to the previous window. So going backwards sometimes is hard, sometimes it's easier to just go all the way back to negative 2 pi and start from there. And we could even keep going if we fill out the graph here. So that's the graph of y equals sine of x. We'll answer the questions in a minute. I think I want to do the graph of cosine next. Then we can compare them, and answering the questions I think becomes a little easier because some of the answers are the same and some are different, and it helps us see, compare, contrast sine and cosine. So let's make that same table for cosine of x. So table of values from 0 to 2 pi, but only counting by pi over 2. We're not gonna do the pi over 4 or the pi over 3 or the pi over 6. If you really want a super accurate graph, you could, but that's overkill. This will be plenty good enough. So while you're making that table and thinking about it, I can pick 5 more people to help us out. So heavy on the right side of the room here. All right, Austin, what's the cosine of 0? So there's 0 degrees. Cosine is the x-coordinate, so it's 1. Derek, how about the cosine of pi over 2? 0. JD, the cosine of pi.
-1.
-1. Austin, the cosine of 3 pi over 2.
0.
Yes, sir. Gregory, the cosine of 2 pi. 1, because we're right back to where we started. So let's plot those points and see what it looks like. 0, 1. Pi over 2, 0. And again, if that's all you look at, maybe it looks like a giant V. But if you put in the 0.7s, I'm not even going to write it down, but the pi over 4, all the pi over 4s are at 0.7. So it looks something like that for our first cycle. Then kind of the same thought process. After you make it once around to 2 pi, then your values just start repeating. So you can take that picture and repeat it between 2 pi and 4 pi. And by sticking with the pi over 2's, all our points are either 0, 1, or -1. And again, we can copy that backwards. Oh, that wasn't the best. So now you look at both of them. And they're, well, you tell me, how would you describe those graphs? Wavy? Okay, that's not bad. That's one of the words we will use. They are both waves. They're kind of the same graph. What makes them different? Opposite. Okay, I wouldn't say opposite. Opposite means like change the sign. So if we flipped one, we wouldn't get the other. What would it take to get one to match the other? Can you tell? But if you flipped it, it wouldn't match up exactly, because this would become like that, and that's not what this is. It's hard to see it, I think. But if we shifted it left or right, you can make it match. They're off by what we'll start to call a phase shift, a left-right shift. All right, now let's answer these questions, because some of them are the same. The domain of sine, domain, that's the x values. So you look at that graph, what x values are covered? The domain is the x values, so that's -infinity to infinity. And while we're thinking about domain, let's answer the domain question for cosine. Also -infinity to infinity. What about the range of sine? -1 to 1 with brackets, because we get to -1 and +1. And then it's the same range for cosine, -1 to 1. The period, might be a new word, is how often it repeats. So like, what window do you need to look at to see the whole thing? I kind of highlighted it to Well, if you look 0 to 4 pi, you see 2 cycles. If I look 0 to 2 pi, I see 1 cycle. If I look 2 pi to 4 pi, I see 1 cycle. So the period is just the width of the window you need to see 1 cycle. So that's 2 pi. The graph repeats every 2 pi units. How about for cosine? What window width do you need to look at 2 pi? The graph repeats every 2 pi units. So any 2 pi window, you see the whole thing. Amplitude. The amplitude, here's the definition, from the middle of the graph to the maximum. Or the minimum, since the middle's in the middle. That's what amplitude is. From the middle to the max. From the midline to the maximum. So there's my average value, my middle line. So how far is it from the middle of the graph to the max? 1. The wave goes up and down 1 unit. So be careful. Some people say, well, it looks like that graph is too high. From the bottom to the top is 2. Yes, from the bottom to the top is 2. But amplitude is from the middle to the top, or the middle to the bottom. The amplitude of cosine is also 1. From the middle of the graph to the wave goes up and down 1 unit. Okay, so lots of similarities between sine and cosine. It's the same shape. It's just one of them is they're shifted from each other. So lots of commonalities. The main difference is where they start. Cosine starts at 0, 0. Excuse me, sine starts at 0, 0. Cosine starts at 0, 1. Another way to say that is that the sine starts on the middle, the cosine starts at a max. Sine starts at a 0. Cosine starts at a max. All right, let's turn the page. Now things are going to get fun. Tangent of x. Oh, there's one mistake here. Y equals tangent of x. Tangent is sine over cosine. So y equals tangent of x is undefined when cosine is 0, right? Because you can't divide by 0. So whenever cosine is 0, tangent is undefined. And that means y equals tangent of x. Again, another fix there. We'll have asymptotes. Remember way back, factors of the bottom that were 0 make an asymptote on the graph? It's the same thing here. Whenever cosine is 0, we get an asymptote on the graph. So cosine is 0 when x equals, think about it, although we just did this. Cosine is 0, I think unit circle, when x is pi over 2 or 3 pi over 2. So let's put some asymptotes on our graph at pi over 2 and 3 pi over 2. That's not wrong, but that's only the 0 to 2 pi asymptotes. If I go backwards, there's an asymptote at negative pi over 2 and negative 3 pi over 2. And maybe you get the pattern here. All the odd multiples of pi over 2 have an asymptote. In fact, I just answered that first bullet point, so let's go ahead and fill that in. Asymptotes at odd multiples of pi over 2. Careful, it's not all the multiples of pi over 2, because 2 pi over 2 and 4 pi over 2 reduce. So it's the unreducible pi over 2s, I guess. Now, let's make a table of values. Although our table is going to look a little different because I can't use pi over 2. I know it's an asymptote there. So let's do 0 and pi over 4, and then we'll see where that gets us, and we may need to do one more. In fact, I'll just tell you, we got to do one more. 0, pi over 4, and negative pi over 4. And since we're all unit circle experts, we can pick on some people. Ava, what's the tangent of 0? There's a help. Remember, it's sine over cosine. It's 0. Luke, how about the tangent of pi over 4?
Negative square root 2 over 2 and square root 2 over 2.
So what's root 2 over 2 divided by root 2 over 2? It's a lot of numbers. 1. Landry, how about tangent of negative pi over 4? Negative 1. So let's put all those on our graph. 0, 0, pi over 4, comma 1, negative pi over 4, negative 1. And so those 3 points, that's not a whole lot of information, but we do have the asymptotes there. So there's not, I don't know how else you'd sketch this thing. It looks like that. And then, like the others, it repeats. So it does the same thing in the next window. You can put negative 1, 0, 1 on there, and then sketch in the and then just keep doing the same thing again and again and again and again. I've got four down there. I don't need to keep going. Okay, so tangent, super different than sine and cosine. In fact, it's also different enough from cotangent. Then let's go ahead and answer the questions first. The domain, what's the domain of tangent? Okay, so I heard negative pi over 4 to pi over 4, and I get what you're looking at. But it's more than that, right? Because it goes all the way to the asymptotes. But then I heard negative infinity to positive infinity. That's sort of right, too, but there are x values in there that we aren't allowed to use. So we have to keep kind of a weird statement here. All real numbers except the asymptotes. And the asymptotes are the odd multiples of pi over 2. So there's a couple ways to say this. You can just say the odd multiples of pi over 2. That's fine. But most books are going to say k pi over 2, where k is odd. It's just a little bit shorter way of saying odd multiples of pi over 2. Again, if you want to write it all out, because that makes sense to you, that is okay. How about the range? How far up and down does it go? All real numbers, negative infinity to positive infinity. The period, remember that's how wide the window needs to be to see the whole thing. So how wide a window do you need? Well, 0 to pi over 2, that wouldn't get you all of it. There's one cycle. How wide is that window I'm looking at? 2 blocks, okay. That's fair. And each block is pi over 2. So 2 pi over 2 is pi. 2 blocks. I like that answer. Don't put that on the test. The period of tangent is 2 blocks. Unless you say a block is equal to pi over 2, and then you'd be correct. So any pi window, you see the whole thing. This means that the graph repeats every pi unit. That's what it means to have a period. Tangent does not have an amplitude. It's not a wave. So we'll talk more about that when we get to graphing more tangent problems. But for now, we'll just say it does not have an amplitude, because amplitude is, how far away from the midline are you? Well, that doesn't even make sense for a tangent. All right, cotangent. Y equals cotangent. Cotangent is cosine over sine. By the way, like that whole thing we did about tangent, we're going to now do for cotangent. So it's going to sound familiar, but it's going to be different because things are backwards. Cosine over sine. Cotangent's undefined when sine is 0. And if something makes the bottom 0, there's an asymptote there. So sine of x is 0 when x equals. So what angles have a sine of 0? Think about the unit circle. 0 and pi. And then if you kept going, 2 pi and 3 pi and 4 pi. You could also go backwards, negative pi, negative 2 pi. So let's put asymptotes at all the pi's. Asymptotes at all the pi's. In fact, that's the first question. Y equals cotangent has asymptotes at all the pi's. Sounds funny. I'm just going to say k pi, where k is an integer. So you can use the k stuff, but you got to tell me what k is. K can't be anything. It's got to be an integer. I can't really answer the rest yet. Let's make another table of values. Cotangent, whoops. That's going to be a rough table of values. I should have looked at my picture first. 0 is undefined, so I don't want that. Let's go pi over 4, pi over 2, and 3 pi over 4. That would give me a set of values in between 2 of my asymptotes. Okay, this one's a little harder because cotangent. Let's see. How about cotangent pi over 4? That one shouldn't be too bad, because cotangent is the flip of tangent. Tangent of pi over 4 is 1, so cotangent of pi over 4 is 1. Even though we've never done this graph before, I bet you could guess what the graph looks like just from that one point. What do you think the cotangent of pi over 2 is? Now, either do x over y, or you're probably just looking at the graph at this point. It's 0, and then negative 1. So cotangent is our graph of cotangent. And it's just going to repeat, so I don't need to do any more table. I can just repeat those values. 1, 0, negative 1. When we get to graphing these, I'll usually want 2 cycles. So I've already at 3 here, and I can do more than that. But later we'll start messing with things and stretching them and moving them. But for now, we just want, this is the parent function day. We're learning all the parent functions. The domain of cotangent. How about the domain of cotangent?
All the numbers except for the whatever you call it, the pi.
Yes, all real numbers except for the, whatever things. Yes, that's exactly right. And the whatever things are the asymptotes, and those are k pi, where k is an integer. How about the range? Yep, negative infinity to infinity, all of them. How about the period? This one's even easier, I think. How wide of a window do you need to look at? Pi. If you look from 0 to pi, you see everything you need to see. After that, it just repeats itself. So the period is pi. The graph repeats every pi. And like tangent, it's not an amplitude. It's not a wave, so it doesn't have an amplitude. And so now you look at tangent and cotangent, and you're like, well, those are similarities, but also some differences. Like tangent's increasing, cotangent's decreasing, and their asymptotes are at different spots. So some similarities, but definitely not the same thing. All right, turn the page. These are going to go quicker because we don't do a whole lot with secant and cosecant. Secant's 1 over cosine. The easiest way to graph secant is to start by graphing cosine. So do you remember where cosine started? Did it start at a min, a middle, or a max? Where did cosine start?
In the middle.
Sine started in the middle.
The actual max.
Cosine started at a max. So let's graph cosine first. In fact, we're just going to graph cosine first and ignore secant. Starts at a max, which means it ends at a max. This is sort of shifting to how we'll graph later. So 2 pi later, I know it has to be at a max because this thing repeats. Halfway in between the maxes has got to be a minimum. And halfway between a min and a max is a 0, or a middle. So there's our cosine graph. Now let's extend it out so we get some more to look at here. But once you got one of them down, the rest is just, max, middle, minimum, and just bounce back and forth. Now, that's cosine, so we need to be careful. That's not the graph we're looking for. But that's going to help us graph secant. Okay, so secant has a cosine in the bottom, 1 over cosine. So secant is undefined when cosine is 0. Asymptotes when cosine is 0. And we just graphed cosine, so now it's really easy to see where cosine is 0. So it's easy to spot the asymptotes since we've got the graph. And by the way, this is always how we'll graph secant, is just forget secant, graph cosine, and then adjust off of it. And how have we phrased how secant and cosine are related to each other? Careful, secant and cosine. Sine and cosine are shifts. Secant and cosine, before today, like before we did graphing, when you were thinking of, when you were doing the test yesterday, and when you saw a secant problem, what word was in your brain about how you were going to get the answer? Flip. Or reciprocal. But let's say flip, because that's going to help us graph these. So if you look between, if you just look at that first mountain there, now we can do this numerically, but I'm going to just flip it. And if I flip it, it is insane. If you flip that, you end up with, I don't want to say parabola, because parabola would go, out left more, and this one has asymptotes. But a parabola-looking kind of thing, if we flip that over. And if we flip the bottom one over, and so we just make these u's off the max and min, and there's our graph of secant. So my secant is in blue, and my cosine's in black. That's always how we graph secant, though. You don't really graph secant. You graph cosine, and then do the asymptotes and the u's. Secant has asymptotes at, what would you say? How would we phrase where those asymptotes are? K pi over 2. And we better be careful. We have to say k is odd, because we don't want 2 pi over 2 or 4 pi over 2. We want the odd pi over 2s. Domain? Not quite, because of those asymptotes. So all real numbers except the asymptotes. Range, that's kind of tricky. It does go forever up and forever down, but the range is not all real numbers. But it's not negative infinity to positive infinity, because it doesn't cover all the y values. Again, look at the blue graph, don't look at the black graph in there.
So we have to do the 2.
Uh-huh. Yes. So negative infinity up to negative 1. And we want to include negative 1, because they, despite this picture, they do touch there. Because when you flip 1, you get 1. You put a u in between, and then you go from 1 to infinity. So that's kind of a weird range. The period, how wide of a window do we need to look at to see the whole graph? Let's see, if you look at a pi window like that, you see one of the u's. But if you want to see both of the u's, you need a 2 pi window.
Why do you need to see both of them?
Well, because if the period is how wide of a window do you need to see before you can start repeating. So if you take a pi window and start repeating that, you're going to be missing the down u's. Or the other way around, you could be missing the up u's. The graph repeats every 2 pi units, just like cosine, because it's very much related to cosine. Again, secant doesn't have an amplitude because it's not a wave. All right, last one. This one will go super quick because we know how to do all these things. Cosecant's 1 over sine. So we want the flip of sine. Let's graph sine first, and then we'll do the same thing we did with cosecant or secant. So where does sine start? Min, middle, or max? Middle. It starts at a 0, maybe another way to say it. Which means it ends at a 0, 2 pi later. Or you can just sketch in max, middle, minimum, middle. Good practice to sketch in another sine graph. And then you can keep going. The pattern's pretty easy to follow. Cosecant will have asymptotes when sine is 0. Well, that's easy to find because we just graphed the sine. And then just like we did with secant, cosecant is the flip of sine. So again, it's a little harder to flip a graph and figure out what's going on, but it makes the u's off the peaks and valleys again. Again, be careful. The sine graph is not part of the cosecant graph, but I kind of have to do the cosecant graph in order to figure out, I have to do the sine graph to know where the cosecant graph is. So I guess officially my answer is, is only the blue things, right? But I can't get the blue things until I've got the sine graph on there. All right, I think you can answer the rest of the questions. Today's homework is really easy. I know we covered a lot, and that's a lot to think about, but the homework is pretty simple. So let me pass that out, and you can look at that.